I grew up loving to work on electronics. And of course I started out knowing next to nothing. And now I know a little more than next to nothing, but nowhere near as much as I'd love to know. But nonetheless, it was an actual joy for me to work on electronic equipment. I love to repair it because I guess the challenge of finding what was wrong and fixing it and putting something that didn't work back into operation was, well, satisfying. But then in the 1980s, I was doing a lot of, frankly, free repair work for neighbors and other people. I would usually charge them for parts, but I almost never charged for labor. Some of them took advantage of that, but hey, everybody's a little different. There are good people and maybe not so good people everywhere. But what really stopped me from doing that was what you see here, surface mount devices. Things like this and so on. Now, I understand, and by the way, in the 80s I was getting my master's degree and I was working at a major research facility, and I understood the need to go to surface mount. I'm not one of these people who thinks we should stay in the past. But it made repairing, for me, less than enjoyable. However, I still do occasionally work on equipment. One of my more recent projects resulted in those surface mount capacitors being replaced, and I used that microscope, and I have another microscope that I also use. So it's not that I'm unable to work on these, it's just that it's not fun anymore. And as a result, I repair very little. In fact, I don't work on anything pretty much that was built after about 1980, unless it's something real easy to fix, like just replacing a memory card in a computer or something like that. And I certainly don't do free repairs for my neighbors anymore. So what this video is about is for those of you who do want to work on surface mount equipment, and I still will test it. But if I discover, for example, that something like this IC is bad, I stop there. I don't even bother trying to replace it. It's just, for me, it's just too difficult. But if you are interested in doing that kind of thing, I'm going to talk about devices like this one, which now come with tweezers that allow you to do surface mount testing. And so this video is going to be about SMD testing, surface mount device testing. And in general, that means that you need a pair of tweezers. Electronic tweezers, not the kind you use to pull the splinter out of your finger. Though I suspect maybe you could. Okay, well, enough of that. Let's move on. An alternative to using tweezers is to get these SOIC clips, which work okay on smaller devices. You can even get one that will work on a quad pack. I don't tend to use them very much. I tried them for a while. They work fine, but the truth is that integration has gotten so I shouldn't say out of hand, has become so prolific that even these devices don't really give you much of an advantage. And so you wind up having to look at very, very tiny components with very, very tiny traces. So I will begin by saying, know what you're getting into before you get into SMD testing. the really tiny devices that you find on many boards today are extremely difficult to work with unless you have a pretty extensive lab with stereo microscopes and all kinds of other things. But for some things, SMD testing will work okay. And the device you see here, the DE5000, is one of the better devices, in my opinion, for testing components on an SMD profile. The tweezers work pretty well, and you can also change out the probes for the Kelvin probes that I showed in another video and so on. But basically this device will test inductance, capacitance, resistance. It'll do Q, dissipation, all the things you might want to know about a component. Recently, I purchased a couple of what some people call smart tweezers, or anyway, devices that test, that can be used, that have tweezers to test. This is the Hold Peak HP990B, and this is the, let me turn it around, Global Specialties Lcr 58. Now this Lcr 58 will do almost everything that the DE5000 will do. This will only test resistance, capacitance, and diodes. It will test diodes and LEDs. I'm not going to try to review all of these things. I will point out that if you have one of these devices, you probably don't need a DE5000 and vice versa. In other words, if you buy a DE5000 and you use the tweezers that come with it, at least the model I bought, or the package I bought, had tweezers with it, you don't really need this device. This can be handy because it's a little easier to work with than the DE5000, especially when you're working on a fairly large board and the meter is way over on one side and the component you're testing is way on the other. But and it is kind of handy and mobile and so on. Unfortunately, my Hold Peak does not auto shut off. It says it auto shuts off, but it doesn't. And so I wind up having to remove the batteries from it, and so I'm not going to be showing that device in this video. But if I'm doing particularly SMD resistors, I'll go ahead and get the batteries and put them back in this and so on. But I thought I might also show you a few other devices and methods that you might want to consider if you want to test SMD components. One thing you can do is get a pair of tweezers that will work with a multimeter. This will allow you to use the resistance and capacitance functions of the multimeter, as well as measure voltages across components and things of that sort. I find that this is just as convenient as the Hold Peak. So if I were going to be spending $20 or so, which is what I think this Hold Peak costs, I'd spend it on a pair of tweezer probes for your multimeter instead of the Hold Peak. So where we are now is, if you want to test L and dissipation and that, I'd either go for this Global Specialties or the DE5000, and then I would add a pair of probes for your multimeter. Now, there are some other possibilities as well. One of the devices that I bought early on, back in the, I think it was in the 80s, it might have been the late 80s, to test ESR of capacitors on surface mount boards, is this Electronic Specialties ESR tester. Now, there's a couple of models of this, and quite frankly, I don't use this anymore. You may notice it says no bat up there, which means no battery in it. And frankly, it used to be very convenient, and I actually even used it for through-hole, checking through-hole components for a long time, because it's completely automated, works very well, and if I were still doing a fair amount of repair, I would do that. I would use it. But frankly, there are other alternatives that have come around, and so let me show you a couple of those. Here are a couple of devices that are made by Peak Atlas that I have used. One of them is an Lcr meter. Works pretty well. It doesn't give you quite as much information as the DE5000 or that Global Specialties that I talked about. And it, quite frankly, is, at least the way it comes equipped with these mini clips. It's really intended more for leaded components rather than SMD. However, what you can do, for example, this ESR meter also comes equipped for leaded components, and these are the what it came with. Now, these are interchangeable. You can remove the mini clips and put them on the other meter and vice versa. But what I have done is I have built a cable that plugs in to the Peak Atlas and converts it to banana plugs. Then I can use a pair of tweezers that you can buy that just are the same as those that I showed you earlier that go on a multimeter. It's just a pair of tweezers, testing tweezers, that allow you to use either of these on SMD components, whether in circuit or out of circuit. Now, when we talk about in circuit, we need to point out that when you're testing components still on the board, you need to know that you're going to get some anomalies. You're going to have components that test good when they're not, and components that test bad when they're not. So you get a lot of false positives, maybe not a lot, but you get false positives and false negatives, to use the language of the day. And so let's talk a little bit about the question of what is the ESR of a good capacitor, and then we'll close all this out. You may have noticed when we were looking at this 88 electronic specialists, or whatever it is, ESR tester, that there's a little graph at the bottom that displays green, yellow, red. Along the right-hand side is the ESR, that's the equivalent series resistance, and along the bottom is capacitance. Well, first, whether you believe this chart or not, and it's a guide, it's really not, there are capacitors that actually will test red on this tester that'll still work in some circuits. There are a few that will test green and won't work in other circuits, and so on. So, like everything in life, judgment and experience play a big role here. A person with a lot of experience can use one of these meters and almost invariably will find the bad stuff and leave the good stuff in the circuit. But even a good experienced person can mess up sometimes. And one of the reasons is, I'm not going to do any kind of point-by-point comparison, but here is a chart that came from the Syncor LC102 manual that you can download on the BAMA archive, the Boat Anchor's Manual Archive. And it purports to show the maximum allowable ESR. Let me zero in on that a little bit. aluminum electrolytics per EIA standards. Well, I have compared this chart to the DC88, and they're different. Furthermore, I have compared this chart to actual data sheets, and quite frankly, I'm not sure where they got all of these numbers. It's not that the chart is bad, it's just that it is as much opinion as anything. And they admit in the note that many of the values on this chart were done based on extrapolating available data or experience of others and so on. Now, what's interesting is this is a chart that shows the maximum allowable leakage for aluminum electrolytics. If you look at this chart, you will find a lot more black area, and the reason is that those are the areas where Cencor exercised their judgment. But what's interesting is now this is parallel resistance, okay? And one of the reasons that I point this out is a capacitor can have bad ESR and acceptable leakage, or it can have acceptable ESR and bad leakage, or both, or neither. And that's where a meter like this DE5000 comes in, because it can read both the series and parallel equivalent resistance. The parallel equivalent resistance is what is being shown on this chart, and the equivalent series resistance is what's shown on this one. So, what does that tell us? Well, the truth is that for electrolytics, probably the most relevant factor is the ESR, especially in high-frequency circuits, and by high frequency I mean things way above 60 hertz, like switch-mode power supplies and things of that sort. When you're working at low frequency, and especially in high-impedance circuits, it's the leakage, the parallel resistance that matters. And one of the nice things about the DE5000 is that it will measure that. Now, what's interesting is that this Global Specialties will also measure that. In other words, it has a serial and parallel mode. Let me zoom in on this. You notice right here, serial parallel. It also allows you to switch the frequency. And one feature that's very nice about this one is you can switch the level. Instead of a half a volt being applied, you can use 1/10 of a volt. Well, 1/10 of a volt is almost guaranteed not to turn on semiconductor junctions. Remember earlier I said that one of the problems with in-circuit testing is that you get anomalous results, and many of those are because you are reading not the component you're testing, but actually something else in the circuit through a junction that is turned on. Transistor, integrated circuit, whatever. So, I'm going to close by showing you something that I did with this Global Specialties. Let me move these out of the way because I think it might show up better. And that is, notice that the tips are not the ones, for those of you that are familiar with this device, they're not the ones that came with this device. In fact, they are the ones that came with this hold peak. And the hold peak comes with 2 sets. And I changed the probe tips on my Global Specialties because that allows me, pardon the arm in the way, to plug in these test probes. These are just ordinary multimeter type test probes that plug into these little bumps in the tweezers and allow you to use it like you would a multimeter. That can come in handy, particularly since these devices will read voltage, and sometimes you need to read a voltage that's not across an SMD device. So I don't know if you're interested in that. As a result, I got more value out of my hold peak than I might otherwise have, because quite frankly I don't really use it very much for testing anymore. But it did give me a nice pair of tweezer tips to put on my global specialties, which I do use a fair amount. So at any rate, I hope this overview of SMD testing gave you some ideas about what's out there. Think about what you're doing and how much of it you are going to do before you buy anything. At least that's my suggestion. But if you decide that you want to get into testing surface mount devices, I am sure that you'll find some of the devices I've talked about to be useful. I hope you'll stay tuned. I hope you enjoyed the video. Please stay safe and have a nice day.